Today we will talk, me and my colleague Ricardo Montalbano, about our experience inside the Archicedar project. And we will talk on behalf of our director, Mirella Serlorenzi, that brings to you all the greetings. She was not able to be here and she brings her excuses. And also all the team members that are inside and work together as to this very long project. So just starting with a brief introduction, and after my colleague Ricardo Montalbano will follow to go deeply inside the application, showing live presentation of the GIS, WebGIS. I just want to highlight how long was this project, along these 15 years. It started in 2007 from an initial directly from public institution of the superintendency. In this graph, I just want to highlight two key moments inside this long period that was in 2009 and 2017-19. In 2009 started the heroic period of the project with the very full implementation of the database, with gathering all the documentation and gathering all the archive data. So it was the moment in which much people are involved and really started the knowledge and the awareness about the importance and the complexity of the archaeology of Rome in terms of data collection. And in 2017-19, there was the big switch between the previous application, WebGIS application, and the new one that will be described by my colleague. And during these last 2 years, we reached other kind of results, such as more towards communication of the project with the new website and other activities that I will describe later. Obviously, this kind of long project in 15 years also involves a lot of people, a lot of young archaeologists, and we have to look to this kind of long period project as a kind of learning tool, a live learning tool for a full generation of archaeology of Rome that started with this project and continues to understand the complexity of data collection of such a huge city like Rome. Just to focus on the main project goals, for sure we can highlight that was to overcome years of delay in standardization of processes for the archaeological management of the superintendency, but also to simplify this kind of management and administrative framework, focus on enhancing the process related to the protection of cultural heritage. We focus also to build flexible and dynamic tools and to take also advantages from previous experience that existing inside Rome. You can imagine how many projects exist inside the city. So a lot of data were acquired, a lot of data are still were available at the time. So we want to take advantages and try to collect all together all this kind of information. And also one main goals is to provide new tools in order to better inform the influence a responsible urban and landscape planning. One main goals of the project was always to inform architects, engineers, urban planners in order to give them more awareness and consciousness of the importance of the archaeology and general heritage of the ancient city. And last but not least, in order to offer an online open data WebGIS tool for sharing knowledge. This is the main focus on the last 2 years, to open with open data services all the information that we are able to store in during these 15 years. Obviously, this kind of work could not be done all inside an office, but just creating a network of academic institutions and other stakeholders all around Italy, but also all around Europe. Here is just an example of our collaboration all around with the main institution around Europe. And just going to some numbers, here you can see how the implementation of the system grows along the years, and you can highlight during 2010, 2011, and 2012 was the main phase of collecting data and transportation inside the representation inside the WebGIS. But also, if you look on the geographic distribution of this implementation, it's important to highlight that it's not so homogeneous. I mean that assessing the archives, collecting information, always were depending on the different factors. That is, for example, people that allow us to go and enter inside the archive. So you can focus with this little video how it's not so homogeneous. We try to keep homogeneous inside all the city, but it's quite difficult. And which are these kind of archives? I think this situation is similar in other cities also in your experience. So paper archives with a lot of reports, maps, photographs, very big formats maps, etc. We digitized all thousands of documents and try to collect inside our system. One main result of this big phase is to understand the complexity of the archaeology and create the guidelines for archaeological intervention. This means that always from the start, from the beginning, it was available inside the website, these guidelines in order to inform professional archaeologists that works inside the city for rescue archaeology to have practical tools to manage this and to deal with this documentation. That is very important because such a tool doesn't exist before. So it's very important to them to refer to this kind of standardization, very minimal standardization, in order to have a framework inside which to deal with these documents. But also this kind of information, if we switch to the data itself, not only I'm speaking not only about the archaeological information. We are thinking here for the time of intervention. We can highlight with this graph how the CEDAR project follow exactly the urban development along the century. So we can highlight this focus moment, for example, the fastest area with big urban changes, the major intervention for universal building in the 70s, or the new underground metro activities and works that are dealing during the last decades. About the cost of the project, of this kind of project, in the first part of the slide, you can see the CEDAR cost divided by categories, and as you can see, the blue line highlights how the efforts were always put on the people that are working on the archives. So a lot of money was spent, most of the money was spent towards keeping people and creating work for young archaeologists in order to manage this very huge amount of information. And also, if you look at the distribution along here, CEDAR project has the ability to keep a continuous and homogeneous funding to keep all the homogeneous implementation of the system all along the year. So starting from a very big amount of money and dealing with the less money during the last year, but continuous and always that can always guarantee an implementation of the system. The new website, as I said, in 2020, completely revised, and also in terms of approach, gives to the users new information about the open data services, the guidelines, new tutorials on how to use the system, all the API description. This is very important because we really think that our data should be used from other researchers, our academics, our professionals. So using the API that we provide, it's very important to build other GIS, to build other application and use the data and keep them alive. And so, and description of the WebGIS services for example, UMS and FlashS. This new platform, mainly, my colleague will describe more in detail, is, as you can see, is a distributed platform, and it starts from the user interface that interact with the WebGIS that you will see later. And behind this, there are a very cloud of servers, all managed by the Zoom proxy that can distribute different requests and response, allowing user to be very fast in the interaction with the system. So, for example, who is managing with data, spatial data, are referring to GeoServer or to the Elasticsearch for searching for data. So it's a distributed application. And in the lower part and the right part of the schema, you can see the GitLab and the Jenkins components. That is the last implementation of the system. This allows us to distribute also the development of the system, not only the framework and the data, but also the code itself, in order to allow other developers to join and share how we are working. And this is possible because the Arcosita project joined the Italian Network Scientific Research Network for the GAR Institute in 2013, and this allows us to virtualize all the servers and to keep a very high speed and performances in terms of interaction with the server. So it's just an information to give you. You can read the slide later. And this brings us in the last 2 years in a visual increase of the registered users. I mean, registered users are those who use the system, who manage data, who interact with data. So as you can see from the graph from 2019, we go through a very increase of the users that are keeping on increasing. But CIDR is not only in Rome. The possibility to virtualize and to distribute the platform allow us also to distribute the entire project to other projects, like for example here in Siena, that we are able to clone our project in order to apply to different data, in this case the archaeology of Siena in Tuscany, and in Verona, another example that they allow us to distribute our database model and application to another context. Just some numbers about the website. We have a lot of returning visitors. We are monitoring how people are interacting with the server, and we're very happy that people are coming over and over again to see new information. We have not only national but also international visitors from all around the world, that they are increasing during this last period. The visitor reach the website directly or our channel, towards our social channel, and the main section of the website obviously are mostly the platform, the WebGIS, the open data services, all the information related on how to use the system. And relation to the WebGIS, so not the website, but the application itself. Also, in this case, we have a lot of returning visitors and new visitors that are increasing along the years, and also in this case, national and international. But mostly, I want to highlight how people are interacting. So we have for how long the visitors interact with the application. And we have people that stay for 30 minutes on the application in order to find, to search, to use as a tool for their research. This is very important. It is a very big result for us. And in terms, just to conclude, in terms of long-term sustainability, as you understand, CIDR was made mainly on these main 3 pillars: the data, the user, and the IT components. If one of these is collapsing, all the platform collapse. So our efforts are to maintain all these pillars together in order to advance. So all the efforts are on the growing with users, growing with the people, growing with the qualities of data, but also keeping updated the technologies behind the system. And the next steps, in the short term, we are going to focus on the methods and tools for archaeological impact assessment in support of rescue archaeology. In the short term, we are dealing with in support of the European Recovery Plan in order to provide tools that can inform these kind of activities. And in the long term, we are thinking on a 3D visualization of the entire city of Rome. So I'm very happy to leave the floor to my colleague that will go deeply inside the application and will show you how to the system.
Thank you, Ascanio. Hello to everybody. Before starting with a live presentation of the public interface, I will just clarify what CITAR is not. CITAR is not a comprehensive GIS of all archaeological data of Rome, but it's a tool built for the will of the Superintendency of Rome to manage in the daily work to manage the archaeological excavation. So what you can find within CITAR are the archaeological excavation led by the Superintendency of Rome and all the kind of documentation bound together with these excavations. So mainly we have four logical levels. So the first one is we call the origin of information. Origin of information collect all administrative, topographical, and technical data of the archaeological findings and identify the area where the investigation is. So you have the perimeter of the archaeological excavation. So to every archaeological excavation belongs one or more archaeological partition. Archaeological partition are the real archaeological finds, and we have a very clearly structured to describe and classify this kind of findings. The upper level, it's the archaeological unit. It's a more interpretative level that bound together all the archaeological partition to give a summarize and an interpretation of the whole context. And the fourth level, but today is not on the center of my presentation, are the area covered by law constraints for protection of the cultural heritage. So this is a very useful law instrument, but it's not today important for our reasoning. Now I will go live and I will show you how you can reach our WebGIS. So through our website is www.archaeocitarproject.it/an. So as you can see, we have also a large part of the website in English, so you can explore in every kind of contents, and directly from the website you can reach the WebGIS interface. So now I will show you only the public interface, but we have also a backend that allows all the professional that works every day in the data entry to manage all the process. So first of all, we have different panel, as you can see. So on the left we have a section reserved to the professional, so the archaeologist that works every day on within the project. So here you can, as you can see, we can manage all the information. Then we have a digital library, and we will come back soon on this very powerful tool. Again, we have another tool panel here, so we can search for in different way, for example, by number of the cadastral plan of Rome, or differently, we can search within the archaeological excavation with a full text search here, or with an advanced search. So, for example, we can filter the archaeological excavation by the officers, for example. The same we can do for the archaeological partition. So, for example, here we can write something. So, tombs. Sorry. Sorry, it's not. Doesn't work very well. Or differently, we at the same time we can filter the archaeological part with the archaeological partition by a specific definition. So, for example, we can filter, I don't know, the balneum, and then we can run the search. So we have here all the list of all the balnea found by the digital library, and then from here we can switch directly from a very descriptive we can zoom to the entity here, and we can read at the same time the full sheet with a lot of information. Here, for example, you can see the typology of this kind of the definition of this kind of material, the localization, so the cartographical basis on which this evidence has been drawn, the description and stuff like that. At the same time, we can also explore. We can also explore on the map all the territory. The first thing we can do is to choose which are the maps, the base map we can use. So here we have different layers. The most important is probably the data. So here we have the origin of information. So as you can see, are the perimeter of the single excavation. You can see in yellow here. So if you click on the perimeter, you can explore the. Okay, so here. So you can explore in a very brief sheet here. You have some basically information, so such as the description and the typology of the excavation, a gallery with all the picture. But if you open the full sheet, you can have more detail. So here the code of the archaeological information, the name of the excavation, the date of the beginning and the end of the excavation, other information, very detailed information about, for example, the description, the archaeologists that worked on the excavation. One of the most important section is the documentation. So here you can find a list of all the documents attached to this specific excavation. And from here, this is a very new release of the system. You can acquire the whole documentation. So everything is open data. So here, when you have the icon in blue here, you can download all these documents. So plans, written sources, archaeological reports, and everything. So in this case, you have two ways to acquire document, or the single document. For example, here, by clicking on the eye, you can download directly the documents and open it in your PC. So in this way, you have the original document in the original resolution, or at the same time, you can also download the whole documentation. This is very important because in this way, the Superintendency of Rome have chosen to share all this kind of raw documents with the public. So everything can go, explore the excavation and acquire the documentation and read the reports and everything, even when not published. So this is a very important release. So we have also other kind of filter already here. So for example, you can switch on, for example, only for example, tombs or funerary monuments, and here you have a filter on this kind of findings, or for example, hydraulic infrastructure, and in this way you can construct your own maps depending on your needs. We have also cartography, important cartographic resources. So for example, we have the Pianta del Nolli, thanks also the colleagues of the Stanford University and other American university, and this allows us to also just a second, because I will switch off. Okay. So for example, sorry, because my connection is not very well. Okay. So as you see, in this way, we can we can do an overlay mapping by overlapping the archaeological excavation together with old and historical cartography of Rome. So here, for example, is the Pianta del Nolli, one of the most important of the city, or again, the Forma Urbis of Rodolfo Lanciani, another important resources for the study of the ancient topography of Rome. In addition, we have a lot of Italian technical cartography, such as cadastral cartography and regional cartography, but those are base map. In the same time, you can also switch off any kind of cartography, so you can. Just a second, I will switch off everything. And you can choose also different base maps, such, for example, orthophoto of the city, or simple Google or OpenStreetMap base map. Another very, very important tool of the new CITER is the digital library. The digital library allows all the user a full term search within the whole system. So both databases and every kind of document. So here, for example, I can write a research term such as tomba, tombs, and I can have different way to explore how many occurrences there are here. I would highlight also the timing of the response very, very fast in terms of milliseconds. So here, for example, for the search term tomba, we have 353 results in 351 milliseconds. Here you have three different ways to move on the documents. So here at Schede, you are searching directly within our databases. So searching in all the fields of our databases. Or you can choose also allegati, so attachments. So here you have the documents connected with this kind of research term. When you filter for the attachment, you can also have some metadata about the single documents, and you can have also a small preview when available. When you choose one of these big class, you can also filter different level of filter. So here, for example, you can choose PDF or images and so on. CITER has a very strong OCR system, so optical character recognition. So we have everything is all the texts are automatically extracted when are inserted in the system, and all the digital library has been constructed thanks the Elasticsearch. Elasticsearch is a very strong engine for research, and it's interesting because it has a fuzziness, let me say. So the digital library can return results that contain terms that are similar to the search terms. So the fuzzy queries create a set, we can say, I can say, of all possible variation of the search term, and a set also a specific distance of the research. So in this way, this kind of engine is more elastic than a normal Boolean operator such and, on, or. So this is very important and allow to the user a very good experience in researching data. The last thing I would like to highlight here is that everyone can acquire all the spatial data, so the geometric data of the system in open data. So this is possible thanks to this function, export function. So in this way, you can frame the context of your interest. So here, for example, you can zoom, and using the screen as a clip, a mask of clipping, you can export them in the most important open format. So here, for example, you can export this context in a shapefile on CapML, or also in raster formats such as GeoTIFF on SVG. As far as the interoperability is concerned, in the last 2 years we made a big effort on this direction. And again, on the website, under the open data section, you can also find all the documentation to exploit the public API already existing for CITAR. So in this way, you, for example, thanks this kind of documentation that you can find here in ArcCITAR project piattaforma/open data, everyone can create can request the data inside CITAR in very innovative way. So in this way, for example, you can call the digital library results on the Elasticsearch and all the full documentation you need to exploit the archaeological data of CITAR. Thank you very much.